All right, today we're going to go ahead and get into section 6.1, day 2. All right, the other day we started section 6.1 and we looked at some key vocab words such as chord, secant, tangent, diameter, and radius. All right, today we're going to look at two properties and they involve using a tangent lines. All right, so let's look at our first property. All right, theorem 11.1 will talk about what happens when a tangent line is connected to a radius. All right, so here's the deal. Our tangent line is the red line in the picture, line L. Our radius is the blue line, or segment, AB. All right, what ends up happening is, you'll notice it says line L is perpendicular to AB. So what happens is that when we connect the radius to the tangent, it's going to go ahead and form a 90-degree angle, right where our radius touches the tangent. All right, what essentially is going to happen is we're going to be forming a triangle. So we're either going to connect it to the left or to the right, either way. And you'll notice that's going to form a right triangle. I've got a 90-degree angle in it. So when we go to solve for a missing piece of this, we're going to be using an old formula that we did first semester, the Pythagorean theorem. A squared plus B squared equals C squared. All right, now, we're going to form the triangle on our own, and we've got to make sure that we draw in that 90-degree angle right where the radius touches the tangent line. All right, so let's go ahead and look at one. In circle Q, the radius is 5, and the tangent segment TP is 12. All right, I notice that I have a tangent line touching a radius, so before I get started, I'm going to draw in my 90-degree angle where the radius touches the tangent. Now you'll notice we already have a triangle formed in this picture, so we don't have to form the triangle on our own. We need to go ahead and label its pieces. All right, it tells us that TP is 12, so let's put TP as 12. It tells us that the radius is 5, and remember the radius runs from the center out, so this whole thing is 5. Now, the first part of this question says find QP. All right, so if I look at my picture, QP is this whole entire line, so I'm going to put an X for that whole entire line. Now, we can go ahead and do Pythagorean theorem to solve for that whole red line, X. Let's go ahead and do A squared plus B squared equals C squared. Remember, C is always across from the 90, so I need to use this side as my C. So we'll solve it. 5 squared plus 12 squared is equal to X squared. All right, let's change those to numbers. 5 squared is 25 plus 144 is equal to X squared. All right, let's go ahead and combine our like terms on the left-hand side. That will give me 169 is equal to X squared. Now remember, to free that up, I'm going to square root both sides, and the square root of 169 will tell me that X was 13. So that whole entire side was 13. Now, the second part of this question is a little bit more tricky. So let's look. They want us to find RP. And I'm going to go back and just move some things from my picture. They want us to find what is RP, this little piece here. Now, let's go ahead and use our picture to come up with this answer. Right now, we know this whole side is 13. That's what we solved for to start with. We need to figure out RP, and in order to figure out RP, we need to know what is this green line. No, let's not use green. Let's use orange. We need to know what this orange piece is. You'll notice QR is a radius. It goes from the center to an endpoint. You'll notice there's another radius in this picture. QT, from Q to T, is a radius, so it's the same. So if QT was 5, we know that QR was 5. Well, we can now find RP. If the whole thing was 13, minus this little piece was 5, that means the piece that's left, RP, has to be what's left over, which would be 8. All right, so essentially we're doing the Pythagorean theorem first, and then we're going back to plug it into our picture and solve for other pieces. All right, let's look at another example. How can we mix that picture up on us a little bit? Well, let's look. I've got another tangent touching the radius, so I'm going to draw in my 90-degree angle right away so that I know. I'm going to label my picture. It says that RP is 2. That's this little piece out here. It tells me TP is 4, and it wants us to find GT, the radius. So I'm going to put an X on GT. Now, we're going to use our picture to set up the Pythagorean theorem, but you'll notice I'm missing something on this piece of the line. I don't know what this little part, GR, is. Well, if you look at this picture, there's another radius, and GR is a radius, so is GT. And GT has an X on it. So I can put that X here, and now I can go back and do the Pythagorean theorem. Remember, C is across from the 90-degree angle, so this side is my C. So if I set up my Pythagorean theorem, I've got x squared plus 4 squared equals, notice I have x plus 2 on the hypotenuse squared. Now we're going to clean this up and convert them to numbers first. X squared plus 16 equals, and now I need to do some side work for this piece right here, the x plus 2. Remember, if we have x plus 2 squared, we're going to have to go on the side and FOIL it. We don't have it once, we have it twice. X times x is x squared. X times 2 is 2x. 2 times x is 2x. And then 2 times 2 is 4. Remember, we can combine our middle terms and rewrite it as x squared plus 4x plus 4. Let's go back and replace that in x squared plus 4x plus 4. Now, remember, the hard part of this was the FOIL. When we go to solve it, it's going to clean up. If I subtract x squared from both sides, I'm left with 16 equals 4x plus 4. I'll subtract 4 over, and I'm left with 12 equals 4x. The last I'll divide by 4, and I get x to equal 3. Now, the second part of this question says to find GP. All right, well, here's GP, this whole line. We just got x was 3, so if I plug that in, GP can be found by taking 3 plus 2. So GP is equal to 5. So again, we're going to do the Pythagorean theorem first, and then we're going to go back and use that info to answer anything we need from the question. All right, let's go ahead and get to the second property. Theorem 11.1.3 talks about what happens when two tangents to a circle from the same external point. What ends up happening is it forms like an ice cream cone. And these two pieces become equal off of our circle. So the two tangents become equal to each other. So AB equals AC, so to solve it, we're going to set the two pieces equal to each other. All right, so notice in example 3 here, we've got two tangents coming off of a circle. Therefore, they have to be equal to each other. So 4 plus 2a has to be equal to 5a minus 32. Let's solve it. Subtract 5a from both sides. All right, I'm left with 4 minus 3a is equal to negative 32. All right, let's move our 4 over. I'll subtract 4 from both sides. I'm left with negative 3a equals negative 36. Divide. and we should get a positive answer for A. A equals 12. Now remember, after we get our answer, we typically have to go back and plug this in. So let's go ahead and plug it into the piece that they asked us to find. They asked us to find HG. Well, to find HG, I'm going to plug it into that equation, which says 4 plus 2 times 12. 2 times 12 is 24. 24 plus 4 tells us that HG is 28. All right, so the ice cream cone, we set the two pieces equal. We solve it, and then we go back and we plug it in to find the missing piece of what they're asking. Let's look at one more, and then we'll try a couple examples, a quick review of everything we've done the last 2 days, and then we'll get into some practice together. All right, here we go, our ice cream cone again. I've got 2 tangents coming off a circle, therefore I know that these two have to be equal. Well, n plus 3 has to be equal to 2n minus 1. Let's solve it. Subtract 2n from both sides. I'm left with negative 1n plus 3 equals negative 1. Subtract 3 from both sides. I'm left with negative 1n equals negative 4. If I divide by 1, negative 1 I get n equals positive 4. All right, so remember, we should always get a positive answer when we solve these. Now, we're not quite done yet because it says find RS. So let's go to the line RS and let's plug it in. If n was 4, I'm going to plug in the 4 plus 3. So RS is equal to 7. All right, so ice cream cones, set them equal. All right, let's go through some example problems, some review. We'll do one of each that we've done the last 2 days and go through them to make sure you're all good. And then we'll go ahead and get into some practice and see what you can do. All right, extra practice number 1. Name us a chord. There are 2 chords in the picture. They run from an end to an end. So WR is a segment that goes end to end of the circle. Or I could use VT as a segment from end to end if I stop at V and T. All right, a secant. A secant is a line that goes through the circle. So this time I need a line with arrows going through the circle. You'll notice VT is the only line with arrows that goes through the circle, and a secant is a line. So when I write it, I'm going to put arrows above it to show it's the line that went through the circle. A tangent is a line that touches the circle. You'll notice this line over here with arrows touches the circle. It only has one letter on it, or one letter by it, so we call it line S. All right, a diameter, remember, goes from one end to another end, but it must go through the middle. So you'll notice this line goes from one end through the other, and it runs through the center, through the middle of the circle. It must run through that center point. All right, our last one is the radii. You'll notice we want to start at the middle and work to the end. So if I started at the middle and worked to an end point, QW would work as a radius, or QR would work. All right, so there's an example of identifying the key vocab words from a picture. Let's go to extra practice 2. All right, we're going to try to find the radius for each circle. Notice circle D is this little purple circle. So when I do D, I want to connect the center to an end and figure out how far I traveled in the purple circle. You'll notice if I count how far that traveled, I went a total of 2. Now be careful, point C is in the big circle. So if I trace the big circle and I were to form a radius from C to the end, and I count how far we went 1, 2, 3, so I'm a radius of 3. Now, remember, point of tangency is the point where the circles touch. The point where the circles technically touch at is right here, my blue dot. That ordered pair is right 1, 2, 3 and up 2. So my ordered pair where they touch is 3, 2. Now, when I go to do my equation of the tangent line, I want to be able to draw a line through that, but I don't want to split the circle. So the only way I can draw a line through that point of tangency is a vertical line straight up and down through it so that I don't split the circles. Now, before we did horizontal lines, and those were always y equals. If it's a vertical line, it should be x equals, and it should be the number that we went through the x-axis at. We went through at 3, so our equation of the tangent line is x equals 3. All right, well, 3 and 4 are from today's material. Number 3, it's tangent with the 2 ice cream cones. It looks like the ice cream cones, so I'm going to set them equal. 2 parenthesis 3 plus 6x is equal to 14x minus 8. Remember to distribute first and rewrite it. So 6 plus 12x equals 14x minus 8. Let's solve. Subtract 14x from both sides. I'm left with 6 minus 2x equals negative 8. Subtract 6. I'm left with negative 2x equals negative 14. Last, divide both sides by negative 2, and I get x to equal 7. Now remember, we typically have to go back and plug this in. It says find FG. Here's FG, so let's plug it in. FG will be equal to 14 times 7 minus 8. Well, if you calculate that, 14 times 7 will give you 98 minus 8 tells us 90. All right, here we go, the last one. I have a triangle that formed from a radius and a tangent line. So first, draw in your 90-degree angle where they touch. Now remember, we're going to do Pythagorean theorem. The question says find TP, so we don't know what TP is, so we have x. Now here's the problem. Before I can set this up, I need to know what this whole side equals. Well, they tell us in this picture that this right here is 9, the radius. So that means from here to here has to be the same because it's a radius, so that is 9. So the whole length of this, if I do 9 plus 32, I get 41 for this side. Now let's go ahead and set up our Pythagorean theorem. Remember, the side across from the 90 is our C. So I'm doing 9 squared plus x squared is equal to 41 squared. Convert them to numbers. 81 plus x squared is equal to 1681. Subtract 81 over, and I'm left with x squared equals 1600. Last, go ahead and square root both sides, and I get x to equal 40, which is what they wanted, which was TP. So, when it forms the triangle, we go ahead and we do the Pythagorean theorem, and then we go back and answer any missing pieces of the question. If it forms the ice cream cone, we set them equal to each other. All right, we're going to go ahead and do some practice now, see what you can do, and we'll go